So friends, in the last class, there was some disturbance in the lecture for last two slides. Once again, I will explain you that part, and then we will move to today's lecture. So here I was explaining the perlitic malleable cast iron and ferritic malleable cast iron. So these are the two microstructures of perlitic malleable cast iron and ferritic malleable cast iron. So cast iron, white cast iron don't have the free carbon, but when malleabilizing treatment is carried out, then due to soaking period, the graphitization reaction takes place. Two graphitization reaction takes place. First graphitization reaction takes place here. I will show. So here 20 to 50 hours, whatever written, at 900 degrees Celsius, first graphitization reaction takes place, and then it will give finally austenite plus carbon. That carbon is in the form of rosette. So complicated group. So that is called as a rosette group. When you cool it with two different cooling rates, you will get either perlitic malleable cast iron or ferritic malleable cast iron. With moderate cooling, you will get perlitic malleable cast iron. That is because of cooling, austenite converted into perlite and carbon remains carbon. But once again, if you cool further slowly, the austenite converted into perlite in stage 1 up to that 760 degrees Celsius. But there is a perlite. Perlite is nothing but mixture of ferrite plus cementite. That is alpha plus Fe3C. It's received from the perlite. It again starts the second stage of graphitization reaction. And 3Fe goes to alpha and carbon again in the form of rosette, and final structure is ferrite plus carbon. That is carbon in the form of rosette. Now the white cast iron is studied on iron carbide diagram, whereas grey cast iron is studied on iron graphite diagram. That part also I told you. So these are the microstructures of malleable cast iron, converted from white cast iron by malleabilizing heat treatment. So I will repeat the statement once again. Grey cast iron is converted into nodular cast iron by melting and pouring, whereas this white cast iron is converted into malleable cast iron by heat treatment. So perlitic malleable cast iron, little strength is there. It is used for making the gears, axles, crankshafts, whereas ferritic malleable cast iron have little deformation properties, used for making the pipe walls, auto parts, etc. And if the cooling is in between, the graphitization reaction will be incomplete and the structure will be ferritic perlitic malleable cast iron. That is P plus alpha plus C. So this screenshot you might have taken. Now in general cast irons are explained here. If you cool slow with addition of magnesium, that is nodalizing element, it gives SgIn. So shape of the graphite is shown there. If you cool slow only grey cast iron without addition of Mg, it gives flake structure. The microstructure is shown there. And if you cool fast, it will give white cast iron. And if you give heat treatment to white cast iron, it will give malleable cast iron. The rosette carbon is shown below the malleable cast iron. So in general, this is the formation of cast iron. Last bit of this chapter is alloyed cast iron. So if you are going to add the alloying elements in the cast iron, further properties are going to increase. So please take screenshot of it. So alloyed cast iron is nothing but cast iron is added with alloying elements. Why? Cast iron are having low impact resistance, low corrosion resistance, and low temperature resistance. And it can be improved by addition of alloying elements like nickel, chromium, molybdenum, vanadium, silicon. Okay. So there are three types of the alloyed cast iron. One is nickel hard, another is nickel resist, and another is silal and nitrosilal. So what are these? One or two are white cast iron and other are grey cast irons. So it is white, this I am explaining now, nickel hard. So it is white cast iron with addition of nickel and chromium. So it is having around 3.5% of nickel and it gives hardness up to 500 to 700 BHN. So if you take normal white cast iron, it has some hardness value 400, 500 BHN. BHN long form is Brinell hardness number. We are going to see in the next session what is meaning of hardness measurement unit. So if you add these alloying elements, it further gives improved hardness. That's why the name of alloy is nickel hard. And nickel is austenite stabilizer, friends. So along with hardness, toughness is developed because of formation of austenite at room temperature due to nickel. Next one is nickel resist. It is a grey cast iron. Larger amount of nickel is present here, but it is having good corrosion and erosion resistance than your ordinary grey cast iron. And it is used for impellers, pump bodies, and wall fittings. If you have seen in the movies, some of the Hollywood movies, so big pump impellers, these bodies are made up of cast iron. Next one is silal and nitrosilal. This 5 to 7% of silicon is added in the low carbon grey cast iron. Now, what is low carbon grey cast iron? So, range of grey cast iron is 3.2 to 4.5. So, low carbon grey cast iron means around 3.5% of carbon. So, addition of nickel and chromium reduces the brittleness. So, this alloy is used for gas turbines, its components, exhaust manifolds, crucibles for melting the aluminum and low temperature alloys. So you have studied manufacturing process. In the manufacturing process, you might have heard the word crucible. Crucible is one pot in which you are going to put the scrap and you are going to melt it. So that's crucibles are made of this alloyed cast iron, that is grey cast iron. Okay, so this is the part which we have covered in the last lecture. Now at end, I have displayed this test. I have sent the Google form link. You please write good handwriting because you are writing at home. Your everything reflected in the presentation. The way in which you are writing, the figures you are drawing. Draw the neat sketches with the pencil, and again you write the roll number on each and every page. Okay, and upload that on the Google form which I have. Link is given in our WhatsApp group. So this was about the cast iron. In this way, we have covered 2 chapters. Now third chapter is non-ferrous alloys. So I repeat, in the start of lecture, I told some modified syllabus where chapter numbers are up and down, but now it is remodified to earlier case. Once syllabus will be uploaded on the university website, I will follow it and I will forward it to you. Contents remain same. Okay. Now let us go to the next lecture. Next content, introduction to non-ferrous alloys. I hope screen is visible. Abhinay.
Yes, sir, visible.
Okay. Now, before we start with the actual contents, let us concentrate to the word non-ferrous. Up till now, we have studied ferrous alloys. Ferrous is iron. So, all the alloys which have iron as a base, that is Fe. Now, why classification is made as a ferrous and non-ferrous? That part already I have explained you in lecture number 1 or 2. In ample amount, the ferrous content alloys are available in the universe. That's why it is grouped at one place and all remaining alloys are grouped at the other place. So, the alloys which have base other than iron are called as non-ferrous alloys. So in steel and cast iron is a base. That is Fe is main element, base element, and then other alloying elements were added. Here, other alloying elements are acting as a base. Which are these? Following are the non-ferrous metals. Read it carefully. The alloy which are having base other than Fe. Following are the actually by mistake no ferrous is printed there. Actually, it is non-ferrous. Non-ferrous metals: copper, aluminium, lead, tin, magnesium, manganese, tungsten, molybdenum, etc., etc. These are metals with single unit. These will act as a base, and you are going to add other elements into it. When you add other elements into base, that combination becomes alloy. So which are non-ferrous alloys? That part is covered in the chapter number 3. So in this chapter, we are going to cover copper and copper alloys, aluminum alloys, and lead tin alloys. And it includes study of properties, applications, and microstructure. Okay. So before we go to next part, let us see this picture. So in day-to-day life, you are observing number of. So some of the sanitary fittings, hall fittings, aesthetic parts in the halls and other living are also made up of these non-ferrous alloys. Second picture shows some plumbing fittings. Then some rods are there, wires. At the right corner, aluminium parts are there, automobile parts, rims, domestic applications, then engine, bottles, and at the center you are observing statues. So these statues are made up of bronze. So you know the recently Statue of Unity. So actually, you might have seen the construction of Statue of Unity. Number of sheets are fitted there. So this complete part is not solid. Otherwise, it would have been very difficult. Try to understand. You can go and Google. You'll see the construction of Statue of Unity, where thick sheets are actually used and fitted. But that is also made up of bronze. And right hand side, these two statues of Radha Krishna which you are observing, these are solid, which is produced by melting and pouring. So all these materials, all these components are made up of brass, bronze, and aluminum alloys. Okay, let us see the next part. And one more thing. Actually, whatever sanitary fittings I have shown, I have told you in previous class also. If you go and see the sanitary fittings at your home, you will find it is steel. But if you see the used taps, means maybe from last 3-4 years you are using, you will find the steel coating get vanishes, and inside you will observe some yellowish part. So actually, sanitary fittings are made up of brass and bronze, and later the steel coating is given on it. Okay. So let us see in detail what are the contents and what are the properties. Now, let us start with copper alloys. Copper. In Marathi, what is the meaning of copper? Who will tell? Madne. Avinash Madne. Tell me, what is local name of copper?
Tambe.
Correct. Now you don't mute. You keep unmute. Madne. Why you are muted? Now tell me, what is meaning of brass and what is meaning of bronze? Again, Madne. What is meaning of brass and what
Brass
is meaning
means
of... In Marathi you tell. Hello.
कॉपर आणि झिंक असते, brass असते, आणि ब्रॉन्झ मध्ये कॉपर प्लस अदर एलिमेंट.
No, I am asking the Marathi name of this brass and bronze.
Marathi.
But local language. You can tell in Hindi. Who will tell?
I don't know.
Huh? Dhondiram Wagmare. Roll number 20. Roll number 20.
Hello, sir. Yes, sir.
Please tell, what is your understanding by the word brass and bronze? Who will tell willingly?
Sir, brass means pital
Correct.
and bronze means
Bronze.
ते ऑलिम्पिक मध्ये पदक असतं ते कांस्य
Yes,
पदक
correct.
कांस्य काय
Tell the name of it. कांस्य पदक. Okay.
ते ऍक्च्युली मेटल कांस्य म्हणतात ना त्याला काय
It is kansya. Kansya means bronze. So let me clear for everybody. Copper is this we can say as a tamber, and then you are adding some elements into the copper to make it brass and bronze. Brass is called as pital, and bronze is nothing but kansya. That's why in the number of competitions, gold medal, silver medal, and bronze medal. So Suvarna Padak, Rajat Padak, and Kansya Padak. Now we are going to see the details of it. First, left hand side you are observing copper, that is brass, and right hand side copper plus other elements other than zinc. Yes. Hello. Copper plus other elements, these are called as bronzes. Now, copper, that is copper zinc, is further divided into two alloys, that is alpha brass and alpha beta brass. So let us see one by one. Today, let us concentrate on the. Hello, am I audible? Somebody reply.
Yes, sir. Yes, sir.
Okay. So bronzes are copper plus other elements. Which are these other elements? Tin, beryllium, nickel, and aluminum. So when you are going to add nickel, beryllium, tin, aluminum into copper separately, they are called as tin bronze, beryllium bronze, nickel bronze. These all four elements are, and copper is the base. Now these also elements we are going to see one by one along with its properties applications. Let us concentrate on brass. Brass is alloy of copper and zinc. Solubility of zinc in the copper is 30%. Copper and zinc up to solubility limit is single phase alloy called as alpha brass. Copper and zinc above solubility limit is two phase alloy called as alpha beta brass. Logic alpha and beta. So in iron carbon system, we have given the names to the phases alpha, P, gamma austenite, delta ferrite, etc. Beta, gamma, delta, all these are Latin words, and these are used as symbols. It is used for single phase, and when beta phase is there, it will be treated as an intermediate phase. So solubility limit is important. You should start explaining from the solubility limit. So what is solubility of zinc in the copper? If you go on adding zinc into the copper, it will go on dissolving up to 30%. Suppose you take 10 crucibles. So 1% zinc, 5% zinc, 10% zinc, 15% zinc, 20%, 25, whatever 10 pots you will prepare, and you will add zinc into copper, and if you melt and if you solidify it, you will get single solid only. That phase is called as alpha phase. So zinc get completely dissolved into the copper up to 30%. But now you will take one more pot where you are going to add 40% of zinc and remaining is copper. If you melt it and solidify, and if you see the microstructure, you will observe two solids. So that will be another phase is beta. So 40% of the zinc you are going to add. Out of that, 30% get dissolved and remaining 10% will form the intermediate phase. So such alloy is alpha beta brass. These just titles are given according to the presence of phases. Same thing is written. So copper and zinc up to solubility limit is single phase alloy called as alpha brass, and copper and zinc above solubility limit is two phase alloy called as alpha beta brass. Okay. Let us go to next slide. Now let us see one by one what is alpha brass, what is alpha beta brass. Now it is written, these are the brasses with zinc content 30% and balance copper. These are soft, ductile and can be easily cold worked. Now one logic I will tell. Throughout you remember, when there is only single phase, it is always soft. So in case of iron carbon system, alpha ferrite, soft phase. Now don't be confused with the alpha is just a symbol used for single phase. If you use alpha in iron carbon system, that will be ferrite. Here their name was given for that alpha ferrite. Here there is no any name, only alpha phase. Just to understand. Okay. So don't get confused with the word alpha. Alpha is just A, B, C, D like this alphabet. In iron carbon system, it is treated as a ferrite. Many students are confused with this word and they are writing wrong answer, and they are giving wrong answer in the external oral and interviews. That's why I'm clearing this point. Don't stuck up with the word alpha. Okay. Here single is up to 30% and it is soft, ductile and easily cold worked. What is the basic color of the brass? It is red. And if you go on adding the zinc, actually zinc color is whitish color. So if you go on adding the zinc, the color of original color of the brass go on vanishing. And if you add less content of the zinc, for example 8% zinc or 5% zinc and 95% copper, you will observe it is a red color. And you may treat externally, you can say that this is a copper, but it may not be pure copper. It may have zinc content. So you can't judge without observing microstructure. If you go on adding more amount of zinc, then color of this brass change color. 1 minute. Hello. So red color becomes yellow color after or more than 8 to 10% of zinc. That's why you have seen the brass pitted, that is yellow in color. But brass may be red in color also. Pure copper is red, and up to 5-6% of zinc or 8% of zinc, red color remains red color. So in this way, you may see in the market the names red brass and yellow brass. It may be asked in the interview. what is red brass, what is yellow brass. So red brass means a brass in which zinc content is less than 8% or 5%. You can say at less percentage of zinc, color red of this copper remains as it is, and yellow brass is the brass in which amount of zinc is little more than 8% and color becomes yellow. That's why it is called as yellow brass. What are the applications? There are 4 important applications, and why these names are given? Because majority it is used there. Apart from that application, some other applications are also there. So first is cap copper. Now, what is meaning of cap? Actually, cap is cap-shaped small electronic component. So you might have seen the big machineries, PCB boards, and where the small electronic components are there. So a small cap-shaped connector, which is made up of copper, which is not pure copper, 5% zinc is added. If you use pure copper, there may be chances of oxidation. That's why if you add this 5% zinc, it becomes brass. Even it is called as cap copper. 5% zinc and balance copper used for making caps and similar application in electronics. Okay, you can use pure copper, but why you are using brass? Because zinc is a deoxidizer. That's why it will maintain the part without corrosion. Okay. Now, if you increase the content of zinc more than 5, the name is gilding metal. So, what is gilding metal? It contains 5 to 15% of zinc. 5 to 15. Hello. 5 to 15% of zinc and balance copper. Used for decorative parts and imitation jewelry. Now, what happened? I said that when content of zinc you go on adding, the way and yellow color appears. Percentage around 10 to 12% of the zinc, it shows shiny yellowish color like gold. So you other may feel that it is made up of gold, but actually it is gilding metal. That's why decorative parts are made up of this gilding metal. You might have seen the many such parts where you feel that it may be gold, but it is actually not a gold. Okay. Next, that is cartridge brass. What is meaning of the word cartridge? Can anybody tell? Cartridge. Who will tell? Onkar Kale. What is meaning of word cartridge? Tell. Cartridge.
Yes, sir.
Don't know?
Cartridge. 1 minute. Yes. 10 seconds.
You may Google and you may tell. If you are not knowing, then tell me now. You can easily identify on Google. I will tell. Cartridge is cartouche. बंदुकीची गोळी. It's called as cartouche. Okay. So the bullet case. So during the world wars, this alloy is used for making cartridge cases. बंदुकीच्या गोळीचे cover. Okay. That's why It is called as cartridge brass. It is called as cartridge brass. 1 minute. Hello. So now it is not only the application. Similar alloy is used for making other parts also, tubes and similar applications. But majoritarily it is used for making the cartridges. That's why the name of alloy itself is called as cartridge brass. What is it? Its another name is 70-30 brass. It consists of 30% of zinc and balance copper. Now this is the microstructure. How to draw that microstructure? I will let you know. This microstructure may be also. We have studied steel microstructure, then cast iron microstructures, then this structures may also be asked in the examination. It is a very simple single phase alloy. You are observing different color shading because of different grain orientation. All phases are alpha. All grains are of alpha, and shading is different because of different grain orientation. In the practical, we are going to see these actual microstructures of steels, cast irons, non-ferrous alloys under the microscope. Okay. Time being, how to draw it, I will show. You draw correct circle. Actually, I am using the mouse and laptop pad. That's why there is a problem. Some grains are observed like twins. Here it is shown. Mirror images. That is because of annealing treatment. So just give the name alpha. Only one phase. This is cartridge brass. 70-30 brass. Remember the name 70-30 because 70 copper and 30 is zinc. Now, if you add 1% of tin in this 70-30 brass, its corrosion resistance properties, oxidation resistance properties are further increased. And this alloy is used at seashores, samudra kinara, and its applications. So that's why, which are the applications at the seashores? There are pumps, impellers, and similar parts. That's why this alloy is called as Admiralty brass. Admiral, this word is related to Navy. You might be knowing. Admiral word is related to Navy. That's why the brass which is used at seashores for making these components is called as Admiralty brass. And it is 70-30 brass only. Only 1% of tin is added into it. Okay? This is all about alpha brasses. I repeat once again. First is cap copper, high percent zinc, balanced copper. Second is gilding metal, 10 to 15% zinc. Third is cartridge brass, 70-30 brass, 30% zinc. And fourth is Admiralty brass. Okay. Next, alpha beta brasses. When quantity of zinc increases more than 30%, two-phase alloy, and it is called as alpha beta brass. Actually, I told the cooling rate. 1 minute. Hello. Actually, I told you, cooling rate varies in the temperature and rate of cooling duration of dissolution. That is, if solubility limit is 30%, at some temperature, it can be varied up to 38%. depends upon varying in the cooling rate. But normally 30 to 38% solubility is for zinc, but it is considered as a 30%. So when percentage of zinc is more than 30%, it forms two-phase alloy. What happened? Earlier there was only one single phase alpha, soft, ductile, you can easily deform it, you can produce the components accordingly. But when you add zinc more than 30%, so you will find two-phase structure. So this two-phase structure is, we can't cold work it. It is little brittle. How to shape it then? So there are chances of asking the question in the examination. So it was asked earlier in 2-3 times. You might have seen the assignment booklet which is there on the drives. So what are the questions in the old question paper? Justify alpha beta brasses are suitable for cold working. Or second question may be alpha beta brasses are suitable for casting. What is the answer? So you should write alpha beta brasses are having zinc more than 30%. Two-phase structure. So it is not suitable for cold working as beta is brittle phase. See, ordered and disordered structure I have explained you in solid solutions. So below 470 degrees Celsius, the structure is ordered, and above 470 degrees Celsius, it becomes disordered. Disordered means it becomes soft. So if you try to do the cold working, there may be chances of cracking. But if you want to do hot working, you can do it easily because beta becomes disordered and it becomes soft. So you can shape the components of alpha beta brasses by hot working. Now question second, it is suitable for casting. Same way you have to write. Beta is brittle phase. Beta can't be cold work, but it is having more fluidity because of more presence of zinc. So by taking this advantage of fluidity, you can melt and pour the alpha beta brasses to shape in the any to give the shape in as per the requirement. That's why alpha beta brasses are suitable for casting. Okay. Now it is again having 4 applications. First is Moon's metal. It contains 40% of zinc and balance copper. It is also called as 60-40 brass. It is used for making, actually it is wrong. By mistake it is copy pasted. 1 minute. I will erase this. After erasing, you take screenshot. I have erased it. So it is a two-phase alloy. It is used for making the pump parts and similar applications, which you can hot work, which you can produce by melting and pouring. Even your these sanitary fittings and other components, pump parts, walls, all these are made up of Moon's metal because you are going to produce by casting. See the microstructure. How to draw it simple, I will show you. You are observing two phases there. The circle and dendrites of alpha in the matrix of beta. In the same zigzag we draw. I am drawing intentionally. I am drawing this intentionally, this zigzag way. That is the dendritic structure. In this way, you fill complete circle. Don't keep the blank place. In this way. So these are alpha dendrites, and this gap, dark part which is shown in actual photograph, you don't make it dark, keep it as it is, that is beta. Draw beta symbol correctly. Don't draw capital B. This is alpha and beta. This is two-phase structure. Metal. Even you can take screenshot where I have drawn the structure by marker. Next one is naval brass. Now I repeat earlier four process, four applications. So many students get confused and they mix these applications here and there in alpha to alpha beta. So I repeat earlier case of alpha. First is cap copper, second is gilding metal, third is cartridge brass, and fourth is admiralty brass. Here in alpha beta brasses, first is Moon's metal, second is naval brass, third is leaded brass, and fourth is brazing brass. Now naval brass is similar to admiralty brass. In admiralty brass, there is a single phase structure, and in naval brass, there is a two-phase structure. 1% of tin is added in cartridge brass, gives admiralty brass. 1% of tin is added in Moon's metal, gives naval brass. Applications are same. It increases oxidation resistance and used for seashore applications, pumps, impellers, and similar applications. Okay. Now, next is leaded brass. Lead is added in the copper tin. It is not copper and lead. Already copper tin bronze is there, in which small quantity of lead is added, and because of it gives globular structure. This copper and zinc is present as a base. I repeat once again. Base metal is copper, alloying element is zinc, that is brass. In this copper zinc brass, when lead is added, it gives globular structure, microstructure, and increases the machinability. That's why that brass is called as leaded brass. Okay. Now last one is brazing brass. If you go on adding percentage of zinc, the brittleness increases. So that's why alpha beta brasses applications are only up to 45% of zinc. But beyond 45% of zinc, that pure beta will start to appear, and it will become pure beta brass, not alpha beta brass. And because of it, it is extremely brittle, and then again gamma phase will also appear, which is also brittle beyond 50%, and that alloy is of no use. So how in case of iron carbon system, more than 6.67% carbon alloy is not used. Same way, more than 45% or 50% alloy in copper zinc system is of no use. Then what is its use? It gives lowest melting point. That's why it is made usable for joining purpose. And your brazing operation, you know that in manufacturing process chapter last, where the welding, brazing, soldering you have studied, their brazing joint is there. In that brazing joint, filler metal is this 50-50 copper zinc. Almost 50% of zinc is present, not suitable for any application due to brittleness. It gives lowest melting point and only suitable for joining purpose. So this is called as brazing brass. I hope you understood. Unfortunately, I am observing some students get exit from the meeting. Now only 41 students are there. I am going to mark absent in this case. If there is a problem of internet, etc., you have to rejoin once again within 5 minutes, 2 minutes. But continuously, if you are absent, then your number will be treated as absent only. I will check. This is recorded. That's why I can see who get exit from the meeting. Okay. So let me conclude this today's class. So today we have studied non-ferrous alloys. There are two types of non-ferrous alloys, brass and bronze. Brass is alloy of copper and zinc. Zinc is and such alloy is called as brass. Zinc, when added into copper phase, so type 1 is alpha brass, type 2 is alpha beta brass. Differentiate clearly between two more questions. First question, differentiate clearly between brass and bronze. You can see in old, so you have to prepare the points of differences. And second difference may be differentiate clearly between alpha brass and alpha beta brass. So you have to explain all these points which I have explained you now. So alpha brasses, single phase alloy, soft, ductile, can be easily cold worked. 4 applications are there: cap copper, gilding metal, cartridge brass, admiralty brass. Alpha beta brasses are 2 phase alloys, which are beta phase is brittle, not suitable for cold working. Hence, they are suitable for hot working and casting. Applications are Munz metal, naval brass, leader brass, and brazing brass. Both microstructures I have explained you how to draw. So it will be asked for 2 marks or 3 marks in the examination. I repeat last sentence of this lecture as a whatever questions are given to you, you please write, scan and send it. Today is I think Monday. So I will give the time of Thursday to you. After Thursday, I am going to delete that folder which I have prepared. Even you upload, I will not consider it. Okay? By the time this chapter will be finished and second test questions will be given to you in the next week. So please hurry up. Thank you very much. You can exit.